Okay. Yeah, I think we finally got the audio balance set right. All right, folks. Thanks for joining the next episode in our Cloud Computing Basics meetup. Yet another trial in terms of how we wanted to get online and get this message out to you folks. We'd actually had a request from the group to talk a little bit about choosing a cloud provider and the models that sit behind that. And so that's what we wanted to talk about today. I did actually want to try to make this an interactive session. We had done Google Hangouts in the past, and that still didn't quite work. There is this is YouTube Live, and I think I have the right pieces working here for this to work. There is a chat option here, and I hope you've seen. I've actually been trying to chat against that, so that might be the best way for us to get at least questions. And certainly, if there's additional commentary, we want to, but hopefully, we'll still find some use both ways. We will stick around for a little while after the couple. I think I prepared about 10 slides here just to try to set questions. We can answer them. There's also we can try this Google feature as well. So in the slides here, I'll make this full screen in a second. There'll be a little banner at the top, and that'll be another way to ask questions through this Google slide presentation model. So we can try that as well. Lots of ways, hopefully, to get questions. If you have a question about this topic, it's an interesting topic. I'm sure we could talk for many hours on it, and then we can expand from there. So with that, let me just switch this over to full screen view so that hopefully this slides over. We now have a full view of the slides. So really the point in this topic was to look at what it takes to choose a cloud provider. I have lots of ideas on that. Thinking about it, there are lots of topics that we could get into. I want to focus on effectively the deployment models as a part of that question in terms of what that cloud should look like, what resources are there of interest. We've talked in previous sessions about the NIST model. We could always talk about that again if there was a great deal of interest in it. But again, I want to talk about the deployment models, public, hybrid, and private, really. Community is an interesting version of that discussion, but to me, it sort of maps into the hybrid space. So there's a different ownership model between private, where it's very clearly owned by an organization, and public, where it's very clearly owned by a third-party service provider. So with that, I want to dive a little bit into sort of the real thought processes that at least I have around this. The first thing I think that's important when we're thinking about cloud users and cloud user needs is really this question of what are they trying to accomplish? What are your users? So if you're the decision maker trying to select a cloud, or if you're an application developer or an infrastructure operator trying to make a decision on a cloud, the first thing is, what are the actual users of that cloud looking for? Are they looking for provisioning speed? Are they looking for a specific service model? That's obviously going to have a huge determining factor in terms of which cloud we're actually looking for and how we're trying to accomplish that. When we talk about provisioning, I think that there are many users of cloud services. The cloud advantage, the cloud benefit is sort of the on-demand and self-service aspect. That doesn't necessarily mean that we've gone full-on programmatic interactions, integration with the services. So we have this concept of manual interactions and manual provisioning as a part of that sort of vision. There's also a question of the actual resources that are going to be provisioned. If I want to provision bare metal, even if I'm automating that might actually have an effect on my provisioning speed. There might be real value to that, but it's going to be an important aspect to what my users need. What kind of services do I need? Also, sort of is going to steer me towards a set of cloud providers that can provide those resources. Not everybody can provide bare metal in a public cloud environment. If you're building your own private cloud, you have a lot more flexibility. The service models aspect is sort of similar to that. Am I using containers or virtual machines in terms of the compute infrastructure that I'm looking for? But also, the service model in terms of the actual application deployment, application development lifecycle. If I'm deploying a set of appliances, then potentially I don't need continuous integration as a service enablement function. I don't necessarily need automation. I just need to be able to upload my virtual machines, my appliances, and enable them and potentially configure them in some fashion. On the other hand, if I'm actually trying to build a full end-to-end DevOps pipeline or support my users in building a full end-to-end DevOps pipeline, then I'm probably going to need programmatic interfaces, and preferably ones that don't lock me into a single vendor so that I continue to have some choice in the matter. So that's the first thing. What are my users trying to accomplish? The second thing is utilization patterns. This comes down to also not just how am I going to use it, which we sort of just talked about. Am I doing this programmatically? Am I automating these sorts of services and capabilities? But also, am I actually finding appropriate ways for actually integrating my application deployment models? So there's a part of the cloud world that is very much about scale out services, scale out applications and environments, and there's a part of it that is it is really looking at more efficient ways of managing IT infrastructure. And I think the difference between the two really comes down to utilization patterns. If I'm using this as a way of dealing with traditional IT infrastructure and providing a potentially more cost-effective management process because I've enabled my end users, my application consumers, to use the system more efficiently, that's a very powerful use case, but it might actually lead us down a path, we'll talk about when we look at costs, that might lead us towards a private cloud model because of an understanding of the utilization patterns. The public cloud, while it's absolutely valid and very functional for long-term, long-running applications, the real benefit, the biggest benefit you get out of the public cloud, at least from what I've seen today, are probably two big things. One, just service reach, the ability to talk to the entire world at any one point in time and really get the most value out of that entire service approach. The other one, though, is speed in provisioning and release of resource. Again, going back to the NIST model, one of the key things in the cloud resource space is this concept of elasticity, this concept of turning service on and off. And that elasticity is something that I think ties right into those utilization patterns. How do I use cloud? Am I automating the services? Am I using one of the CAPS tools to actually manage the application that's being deployed into the cloud environment? Or am I really just deploying static systems that are going to live there for a long time? So utilization patterns are important. Now, utilization patterns alone don't define a particular cloud as being the most appropriate. That they might sort of provide some initial high level thoughts, but they're not always the best and simplest. So cost management. This is probably where all these things start to come together. So we start to understand how our users want to consume their cloud. We understand how our users are trying to scale their applications. Am I turning things on and off rapidly, part of an integration and development pipeline, or am I just deploying application services and letting them run for a long period of time, effectively a different version of IT management? Again, both can be valid in public or private or even using hybrid cloud use cases, but understanding them also drives your cost management very specifically. There are sort of transition points, inflection points where it makes more sense, even if you're running only a couple of static instances, where it starts to make sense to actually run a private cloud versus a public cloud. Now, there are a lot of factors that go into that, and we'll talk about some more of those in a moment. But again, I just wanted to reiterate that I'm hoping that these conversations can become more conversations rather than me just lecturing at folks. Much though I like lecturing and enjoy that, I'm really hoping that over time this becomes a little bit more of a discussion. We have both the chat on the now YouTube live channel, so hopefully you can chat there and hi to the folks that are joining and see that. Also, the little bubble here at the top. If you go to that, you should get a little Q&A session. So if there's a question that you want to ask, then this is potentially another way to do that. Actually, the nice thing about using this Google Slides link is that I can then pop that onto the display, and everybody can see the question typed out, which might be even better than me trying to reiterate the question. Anyway, So we know that cost management is an important aspect to this. So we know what our users are trying to do. We know kind of how they want to use it. We are starting to understand cost from the perspective of use. Am I leaving these things running? That's going to have one model of cost. Do I need something where I can constantly increase or decrease my services? That's another thing. How am I going to determine what that looks like? And John wanted to try something. Yes, I can see this. See, so we get to present the slide. I think that's actually kind of a cool way to hopefully have you guys ask questions that are meaningful for everybody, and then we can discuss them. Well, discuss is maybe a little one-sided, but anyway, so we can at least talk about them. But anyway, so going back to the cost management thing, there are two aspects here. One is that understanding the monitoring, what tools we're using to monitor services. If I'm using services that are applications that I want to deploy myself, I can deploy those as appliances, as virtual machines that sit out in the public cloud versus the private cloud. But the key here is that I'm collecting this data. The alternative is that I can actually implement the questions in a very consistent fashion. I can also start to use third-party tools, and those third-party tools might give me better visibility in how my actual users are consuming the cloud resources. What that really gives me, though, is the ability to start creating either a chargeback model or a billing model for explaining to my users what they're consuming. This comes back to another bigger aspect of cost management for me. When I'm looking at using a cloud, I can go onto the website of any public cloud and at least get an idea of what an ECU costs, or basically what a 1 CPU, 1 gig of memory virtual machine costs. I can get an idea of what a processing thread in a platform model might cost. But I don't have a very easy way of saying, well, given that I know what those costs look like, I can't necessarily determine what my actual cloud spend might look like unless I understand how my users are actually going to consume those resources. If they just turn applications on and leave them on, then actually it's a very easy calculation. You can determine the scale of your compute resource that gets consumed, and you can actually then map that out over time and say, well, I know how much my cloud is going to cost, and then I can map that to what it would cost me to run a private cloud potentially, or run these services internally. And that's how I can determine if one model is better than the another. Simple way. When I start, these monitoring integration tools really come into the forefront, because I can actually see what's being consumed. But there's another aspect to this, which is that we'll look at, which is end user awareness. When I'm looking at costs, though, it's often easy to get caught in the thought of, well, how much compute am I using? Am I using lots of static VMs? Oh, maybe a private cloud makes sense. Am I using lots of dynamic VMs? Maybe not so much. There are lots of those interactions that can become very important. But when I start thinking about all the other costs that go into a cloud, whether it's a local cloud, if I want to actually make that private cloud accessible to the public internet, again, private is not necessarily the end user view, it's the access to that resource, right? So private cloud tends to be something that an enterprise might build for their own use, but that doesn't mean that they're not going to expose the applications to the internet at large. And so when we think about network interactions, one of the things to be aware of is that if your application is very network heavy, it may actually be more cost effective, depending on what your actual connectivity capabilities are within your own data centers. It may be more cost effective to actually use a public cloud provider just because of the network costs alone. The shared resources that exist there potentially give you much broader bandwidth than what you might be able to get directly to a data center that you own yourself. Now, this of course depends on system scale and service scale, and you can buy just about any kind of bandwidth just about anywhere in the world as long as you're willing to pay for it. But often this is another one of those shared resources that the public cloud can provide, that maybe you can get better capability there than you could ever afford to provide in a private cloud, especially in a small environment. Another thing are some of the other networking resources. It's not just about bandwidth. Often it's also about networking services. So do I need things like VPN termination? It might be that it's more cost effective to have a service provider provide that and tie this into the infrastructure itself. Is this also due to elasticity? Do you want to expand on that question a little bit, and I can maybe tie into that in the discussion? This was a question Jiro had asked on the chat. Well, if you want to ask more, I'm not quite sure how elasticity applies. Well, elasticity can apply relative to the overall cost of cloud for certain. When we think about the ability to increase or decrease consumption, network interactions, compute interactions, and even storage interactions, which is actually the next slide. Yes, the need for public versus private. Elasticity, though, is something if you size your private cloud appropriately. Again, this comes back to understanding what your users are consuming. One of the things that comes from that is understanding your user needs. If you understand your user needs and you understand that they might at times need 1,000 compute instances of a certain size or a certain scale, then you can build a private cloud that can support that extreme end of the service. On the other hand, public cloud potentially has much greater capacity, and so if the elasticity is not understood, sometimes a public cloud is a better resource for that because the elasticity is available. You're going to pay for it, of course, but you can either potentially pay up front in a private model, or you can pay over time in a public model. So elasticity is one of those components that ties into this. So we've talked about compute, we've talked a little bit about network. I wanted to talk about storage. And I think all these pieces will come back to that elastic question, because I think when we start talking about public versus private versus hybrid models, there's some good trade-offs that can be exposed. Again, understanding the usage models and use cases that exist. And that also might, those elasticity questions might also drive which cloud is most appropriate over time. That might change, right? So elasticity might actually drive a change in one cloud to another, or vice versa. Looking at the overall costing of clouds, one of the things that's often a hidden cost, at least up front, is storage. Again, if you're going to size a cloud, if you have an idea of consumption models, then storage is something that you can allocate based on the potential for resource utilization. It's much easier in a public cloud because there you potentially have a much higher elasticity component. I can get as much as I want, but you're going to continue to pay for that. And one of the things that people often don't think about when they make a decision between a public or a private cloud is what is the cost of that storage. They might look up front and say, 25 cents a gigabyte a month. Well, geez, that's cheaper than what I can buy off the shelf. At the same time, if they start building terabyte data sets, there's a storage aspect that people don't often think about, and that is the bandwidth cost that goes along with that. If those data sets are data that are being built by the application, one thing that ends up happening is you effectively start tying yourself more and more to a particular provider, whether it be public or private, because of the size of the data sets. I've worked with plenty of companies that actually already have very large data sets. I wouldn't necessarily go so far as to characterize them as big data sets, because they may not be used in like a map reduce sort of a sense, but they're very large data sets that are a part of what their application wants to have access to. So one question is, do I now transition that entire data set into the cloud environment, into the public cloud or potentially private cloud environment? That might actually incur bandwidth costs, although I think most providers are willing to give you free bandwidth inbound. So basically, if you want to upload multiple terabytes of data into their storage cluster, they're happy to suck it in, but every time you release it to somebody, you're going to pay that bandwidth cost again. So that's something to sort of consider. So there's a question here from Kumar. With the assumption of a company using traditional data center and let's say 100 users, is there a way to figure out how much cost of running the entire environment in a private cloud? So one of the concerns in trying to make blanket statements is a question of consumption. I did one model for a customer where we were looking at an environment. They were basically an appliance-like environment. They were not doing a lot of DevOps, dynamic deployment services, so they didn't suddenly need 10,000 VMs to do a pile of development validation work and then release all of those back into a large pool, which would be a good public cloud use case potentially. Instead, they were looking at deploying appliances as services to support their users. They did have some development that was going on, but the developers were not developing rapidly. It was fairly static development that was going on. In that case, their break even seemed to be around the 150 large equivalent instances. So when they were deploying their appliances, none of these appliances were single core, single gig types of systems. They were usually on 8 or 16 core machines with 8+ gigabytes of memory associated with them, and then some storage as well. I would leave the storage in this particular case out of the equation, but that modeling, when they were at about 100 appliances, it seemed like it was reasonable, given that there was a sort of a static load already in their environment, to actually incorporate some of the costs involved in running a private cloud. And I've got a slide here a little bit later where we'll talk a little bit more about some of those costs. And Kumar, if you want to ask another question relative to that, maybe I can help sort of further refine the answer. Unfortunately, a lot of this really does kind of come down to doing an upfront analysis of the business need, looking at a review of the user space, the application development teams, what's going on within the company, what's the outbound facing interactions. And we're looking at all of these resources when we do that. We're looking at what's the network consumption, what's the storage consumption, potential and current, what's the user availability to understand how to leverage cloud best. Right. So we look at all these different resources. We look at the cloud services. We look at the storage network and compute resources and consumption, the models for consumption. And one of the concerns that I've always had when looking at cloud is vendor lock-in. My early days in this space, I was talking to customers that were classic big data center users, and they were just trying to understand how cloud might help them, but they almost to a T came back with the one big value in either deploying a private cloud or even using a public cloud vendor was the reduction of potential vendor lock-in. Now, one thing I mentioned earlier was this question of storage. If I go and load a couple of terabytes of storage into the cloud and then suddenly want to get that out, I might feel locked in because the cost of pulling that storage back from the cloud provider is fairly high. It's potentially a steep cost when I look at the transfer cost in terms of bandwidth. But over the long run, it may be, it all works out in the wash. But understanding the standard interfaces, and by standard, I'm not saying necessarily something that is lockstep, IETF, ANSI, ISO, etc. standard. I'm just saying something that has models that are consistent. A good example there is that the Amazon cloud interfaces, their compute cloud interfaces, are standard of a sort. They're not exactly a standard. All right, there is no standards body that has agreed that the Amazon EC2 interface, for example, is a standard. And in fact, Amazon claims that it is not a standard; is their own interface. You can use it to communicate with their service, but they don't guarantee that it won't change. Right, so standards don't directly apply there. But at the same time, the model for consuming resources, things like the request of a machine, the request of a snapshot against that machine, this concept of a disk that's directly associated with that virtual machine as its sort of root operating system disk, that model is consistent. And we've seen a number of different clouds and cloud management services at that infrastructure level that use the same basically service description to describe that application, that systems environment. And migrating from one to another, while it's not completely painless, is also not really a lock-in concern. Lock-in comes from using other services potentially in the Amazon cloud. If you start using their DNS service, which is a fantastic service, and I highly recommend using it actually, but if you use that, or if you specifically start using their IP addresses as a part of your application, these things potentially lock you in. You start using message bus services and simple queuing services and things like that. Unless you have a way of replicating those services outside of that space, you have effectively locked yourself in. It's basically feature lock-in in that environment. And again, the data migration one is another one that I think comes in fairly often. So it's just something to be aware of. The lock-in component is interesting from a data center services perspective. A lot of the private cloud vendors or customers that I was working with when I was a vendor specifically selling private cloud services, their big value was not so much the private cloud, but the reduction in potential lock-in of those underlying services. The ability to say, well, I can change out my compute resource, my storage resource, and potentially even my network services functions, all while still maintaining my application interface into those services, and that was very powerful. So I said I would talk about hybrid. Hybrid is kind of interesting. There's some problems that I still see with it, and the number one problem I see with the hybrid model is the interaction between the private environment and the public environment from the perspective that most people, when they talk about hybrid, think about it relative to a migration capability. Oh, I can take service that I have in my private cloud and move it to my public cloud, or I have service in my public cloud and I can migrate it to my private cloud. The I don't really think that's the right way of thinking about it. Hybrid is useful if you have different application spaces that need different capabilities. So one really good example is if you start with a public cloud, and you find that you're constantly consuming a certain static resource in that public cloud, it might make sense to migrate from that public cloud back to a private cloud to sort of provide a more cost-effective long-term management strategy for those static resources. Now, this assumes that access is still viable, that the network bandwidth you can provide in a private cloud matches what you needed from the public cloud. Not that it matches what the public cloud can provide, but it at least matches the need. That you have the ability to provide the storage and the backup resources and all the other capabilities that you can potentially get out of a public cloud, but you can do that in the private sense. So you could actually migrate some of your services back and keep the public cloud environment around for that application development and application acceleration. So a very powerful way of thinking about how these things fit together. Also, storage, network services, even the ability to scale an application potentially might drive you to having some resources in a public cloud environment and some in a private environment. And it's that model of hybrid that I think makes the most sense, not this active migration thought. Now, the one place where I think active migration may suddenly become actually viable is in the case of what I believe people are starting to call container as a service. This is not exactly platform as a service in the way that some people think of platform as a service, things like a Heroku or a Pivotal Cloud Foundry sort of tool set. Rather, just being able to bundle your applications not as virtual machines, but as application containers, a much lighter weight way of potentially managing and deploying your application. So in that case, I could potentially very rapidly migrate an application that's running in my private cloud into a public cloud or vice versa, because I'm just moving a fairly small container around. That does imply certain things like the data set that I would be consuming is accessible from everywhere. If my data set lives in the private cloud, then maybe my public cloud has a VPN service back into my private environment so that my scale up or bursting kind of capability is actually still viable in that sort of a case. So that's the real thing that I see in terms of hybrid cloud is that ability to sort of leverage the best of both worlds rather than migrate services around willy-nilly as needed. And the one thing that I think is missing in the community right now is a really good centralized hybrid management strategy. But I think that's coming, and a number of customers, a number of companies are actually looking at providing solid hybrid management tool sets and capabilities. So those are sort of the key things that I think of when I'm looking at cloud and trying to decide which cloud to use, are sort of using those different steps as metrics for determining one model versus another. But the reality is that the best way to actually manage your cloud and understand what it needs, and better yet, get the most value out of your cloud, is to support your end users. These are the ones that are going to use the cloud, and I have seen so many cases where people say, oh, cloud is going to answer my IT concerns. I'm going to go to the public cloud because I can scale up as much as I need to. I can take part of my IT and have them just focus on managing that resource instead of actually having to manage the infrastructure. So maybe I get some cost benefits out of doing that. This is going to be the greatest thing for our business. And the reality is that the actual users that are deploying applications, building applications, using these resources, see the cloud as an endless resource pool and don't ever release anything. Classic issue that I've seen is people get access to a cloud environment that spin up a virtual machine because they can. It's the first time they had access to basically being able to do something without having to go through a bunch of paperwork to turn a service on. And maybe they even spin up a little application on it to see how it all works, and that's about the end of it. The thing that they forget to do, or almost never do, is turn it off. And this is one of the most interesting aspects of cloud consumption, and why I think end users and their habits are sort of the number one thing that you have to address when thinking about what is the right service for cloud for a particular enterprise. I think educating users on how a cloud should be used or could be used is the first thing that you can do. It's going to be more cost effective than trying to monitor users or start to charge back against what they're consuming, because you're always going to get pushback from your users, especially if you're the CIO or director of IT that's trying to manage a set of resources that get deployed. Your end users are always going to come back and say, well, my business need demands that I get access to this class of functionality. So being able to help them understand how their usage patterns, their consumption drives both picking the right cloud for the company and selecting that migration if that needs to happen, but also just getting better service out of the environment. Changing how an application gets deployed is actually a major challenge for many people. This is not like this is an easy thing to do, but it can actually be very important in terms of enabling the best service of cloud. If your users start to understand what cloud means and the elasticity and how that can be leveraged in accelerating their development practice, accelerating their deployment and application management practice, dealing with the failures that are going to occur, providing a more efficient disaster recovery situation, for example, all of these things are benefits that can be derived from using the cloud, but your users have to know how to use the cloud. So I would even come back and say more important than actually picking the right cloud is educating your users on cloud use. Because the model of migrating from one cloud to another, given that there are fairly well-defined consumption models, use models for the different cloud services, I think is something that you're not too likely to pick a cloud that's really going to lock you into one vendor or another. Again, there are services that you might start using that you can't necessarily get in a private version versus a public environment. But even those are probably going to be few and far between. If your users understand how to use cloud, you're going to get the most value out of it. So I think I've sort of touched on the next couple of things in terms of sort of a progression. If you were to start in the public cloud, this is actually very common, whether that be an infrastructure service cloud, I'm going to spin up virtual machines and use them in the cloud, use some of the scale out network services, things like DNS and potentially load balancing services. These are all the sorts of capabilities that a public cloud can provide, and especially a startup or a new project starting up even in a larger company can make a lot of sense in a public cloud where the actual scale of the application, the actual scale of the resources that need to sit underneath that environment are not very well known. They potentially need more understanding, more capability in terms of excuse me, in terms of being able to map their application over time as they develop the application. A public cloud that gives you this massive potential scale is very important. Another thing that the public cloud potentially provides that often people don't think of initially, but it really is a real value, is many clouds are not geo-specific. There are geo-specific public clouds, but there are many that actually span the globe. And suddenly, by deploying into one cloud, you have potentially local reach or the ability to build local reach across a number of different application services. And that's also an incredibly powerful approach to cloud and cloud utilization. So the public model is the first part of that, but it could be that over time, a set of services become static. They become services that are always there. They might scale up and down a little bit. You might still want the automation of the cloud-like environment to help with service migration, service upgrades, things of that nature. But you're consuming enough resource that it actually makes sense to go to a private environment. As long as you started in the public cloud with an eye towards thinking that, hey, this transition may occur. It might be that in 6 months or a year or in 5 years even, we suddenly find ourselves in a situation where having a private cloud makes a lot of sense. Then you can actually think about that relative to some of the resources that you might be consuming. Things like storage consumption. It might actually be that you build a private storage cloud in your own data centers before you actually do that for any of the compute resources that you're using, just because that centralizes where those resources come from. It's often easier to create a point-to-point VPN tunnel and expose just a small piece of storage, even if it's replicated locally so that there's additional sort of boundary layers between the bigger store and the actual data set that's being consumed publicly, that can potentially be much more efficiently managed in a private environment. So this transition is, I think, a fairly common one, and it just makes sense to think ahead and look at the network, the storage, the compute resources that might get consumed in the application space. And as better visibility comes about, look at what that might take to transition into a private environment if the cost model starts to make sense. The inverse also, I think, makes sense. There are plenty of people that have built small private clouds that are saying, well, I'm not getting enough scalability. I've worked with plenty of companies. Actually, I think this kind of comes a little bit back to that whole question of end user education, but I've worked with plenty of companies that have actually deployed private clouds and have had those clouds fill up, much like any other infrastructure resource that they apply, whether it's physical resources provided on a one-by-one basis to project teams, virtual machines provided in the same way to project teams. Often those resources get consumed. They're not necessarily being released, which is one of the reasons that often people say, well, I need better elasticity. My resources just get consumed and they don't get given back. What's the real solution to that? I'm sure you guys already know what I'm going to say. End user education. Help them understand how to actually use the resource more effectively so that everybody gets to share in the capability. And it's a good thing for the business as a whole. So that's always going to be a good idea. But still, there are plenty of reasons why, again, you might want to take something that is private and start reusing or utilizing public resources. And to me, this is sort of the opposite of the previous model, where you might suddenly realize that having a cloud provider in a remote location gives you better accessibility to that region's end users or the customers that you might have in those regions. So using them for data locality, I mean, there are often cases where you actually have to use either a data center service or potentially a cloud in another country just for data locality and data sovereignty questions and concerns. And many of the public cloud providers now have clouds that can address those sovereignty questions just by providing resource in different countries for different end users cases. So, for example, Facebook end user data in Europe stays in Europe because of some of the discovery rules that they have in terms of data and things of that nature there. The same thing can be applied to any application that one might deploy in a business sense. The other thing is that even if the end users need access to data, you might actually find that it's more effective to cache some of your general store of data out at those end user locations rather than providing it all in a fully distributed model. And again, a private environment that eventually spans out into the public to provide better end user reach. Streaming services are, I think, fairly common users of this kind of a model. Can use public to help extend their reach while still having private data management and data maintenance resources. And lastly, hybrid. As I mentioned earlier, probably not the best use of hybrid models for trying to migrate virtual machines around all the time. But there are plenty of cases where migrating from one to the other isn't really the answer. Instead, what you really want is you want the ability to manage data in multiple environments and manage both classes of resources, public and private resources. And the NIST model for hybrid described a user access model, not so much a particular service enablement model. Sorry, there's another question here. Is there a way to allocate cost budgets to specific cloud environments? That's actually a really good question. Often when one tries to model private cloud, the amortization is a part of the overall cost. The interesting thing is that because of the way that cloud resources get consumed, often that amortization just gets factored into the per CPU hour cost of a resource over a period of time. Right? None of these things are very useful as point-in-time calculations. Really, the question is, over a year, am I spending X hundreds of thousands of dollars on compute resources? When I start mapping the different pieces together, what's the right cost modeling for that? And this is really sort of where I started getting into this anyway, is thinking about public cloud costs versus private cloud costs. I think this ties right into sort of the question that you have, which is in our public environment, we're thinking about often cost per ECU, we're thinking about storage costs. cost along with that. And that's something that you can define very cleanly because there is no amortization that gets factored into that. When I think about private cloud costs, I have to look at the infrastructure and the amortization of that infrastructure as effectively a fixed cost, and maybe that even defines the period of time over which I would look at resource consumption. If I can amortize compute hardware, I believe at least in the US, the model is 3 years for physical resources. Most compute elements, servers, and network switches, except for very large systems, often fall into the 3-year amortization bucket. So I'm looking at cloud cost over 3 years. I can use that to also define, well, if I've built the cloud, I need to operate that cloud for 3 years in order to get the best value out of the hardware that I've acquired, which means that I need an ops staff for 3 years. Potentially, I want support for the software that I'm using to run that cloud. Even if it's open source, there's still a support cost, and it might just be that I need an extra ops resource to manage it. The data center space, power, cooling, etc., all those things also have amortization schedules, right? The power conditioning components, the cooling management resources. Heck, the building itself has an amortization schedule that goes along with it. All those things are costs that get involved. I don't think I've ever seen anybody model all of that in a private cloud cost, but often I think you can get close enough by looking at the cost of a resource when it's amortized at least over a year. You can look at that portion of the resource cost. You can look at the data center service space in much the same way, and you can look at your ops staff in the same way. You're not buying those resources on an hour-by-hour basis. Maybe the worst case model is that you're doing that on a 3 or 6 month view. If it doesn't work out after 3 months, you sell off all the resources, you fire your ops staff, and that's sort of the end of the experiment if it turns out that that's what needs to happen. But often, if you model it over a year, again, the inflection point that I've seen that seems to come up fairly often, especially within a public versus private question, is how many servers and for how long. And by servers, we're often talking about virtual machines rather than physical resources, although the model that I've seen seems to be that somewhere around 150 to 200 virtual machines, which maps to about 20 to 40 physical servers, depending on the actual scale of the virtual machines. And then the related storage and network and power, et cetera, services related to that, plus an ops staff. And an ops staff for a 20-node cloud is probably one resource, maybe two, in order to provide some kind of resiliency, especially if you have an operations staff already. That's basically additional resource in an IT environment. If you're building from scratch, one of the things that you end up with in the private environment is that you need to have enough ops staff to deal with basically pager duty for failures and that kind of service. And suddenly you end up with an ops staff minimum of something on the order of 7 people in order to support weekend duty, evening, night staff, and all other resources that would be required to keep an environment up and running full time. Again, if some of that is part of the staff that is a part of your organization, then you get to sort of you get maybe a little bit of a free ride in a certain extent, although you can also model that entire resource into it. But again, 1 or 200 basically large-scale instances running full bore all year ends up basically becoming a sort of a domain of inflection. That's an area where at that point I would start saying, well, should we be private or should we be public? This assumes, of course, that you've started out in the public cloud and are now looking at potentially migrating back into the private space. The inverse of that is if you know that your application space, again, if you know your users, right? Number one thing that I brought up, if you know your users, you can already determine right off the bat, are they going to be able to leverage the dynamic nature of cloud in general? B, are they already going to consume the resource? If you give them 20 physical servers, are they going to consume that right away and basically use that full time 100% because they're not really dynamically consuming these resources? Then the benefit that you get from private cloud is the potential ability to help manage that application in a new way. And that might be the thing that happens over time. So deploying a private cloud in that sense is not so much a cost and performance benefit. It is just a resource management benefit that only comes into play over time as people start to leverage the service more efficiently. So anyway, I said I was going to talk for a half hour. I've talked for almost 40 minutes. That's pretty classic for me, I think. So quickly, Many factors go into the decision. I think we've seen some of those: network service costs, storage systems cost, infrastructure consumption cost. While pricing may be the principal factor that drives somebody one way or another, being aware of what the transition costs might look like over time is actually an important aspect to this. But also, the best way to manage the costs of any kind of cloud is to understand really that user education is a key aspect of this entire solution. If your users aren't educated, cloud is not going to solve your IT problems. It's just going to be yet another one of the headaches that has to be managed, whether it's public or private. And then when we think about managing their utilization, managing the consumption of cloud environments, the number one thing that we find is that it's important to understand the application utilization. So whether you use a tool like a Sensu or use a service like Splunk to capture data, or whether you're using your cloud provider to give you data at the end of the month as to how much you've consumed, understanding what that utilization really looks like, again, educating your users to help manage those costs over time. These are the things that are going to help make decisions about either cloud transitions or which cloud to continue to consume, because the reality is that I think most of us are already using some form of cloud. That's really sort of the key to all of this. And lastly, the question about hybrid always seems to come up. And I think it's really more a question of hybrid management becoming something that's becoming more pertinent, especially as people start to understand whether they have a public cloud or a private cloud, or really do need to have feet in both worlds for different pieces and services, and trying to sort of corral that management into a hybrid management console. So, folks, that's what I had to talk about with you guys today. There were a couple questions asked. I love questions. If there are others, I'm happy to stick around for the next 10 minutes or so and chat about anything else that comes up. Hopefully this provided a good overview of some of the things that you should be thinking about when trying to make a decision. I unfortunately, every case is a little bit different, so it's really not something that, other than sort of giving you some rules of thumb like I have, right, 100 plus large scale compute instances running 100% of the time, probably a point where you might look at the costs of building and running a private cloud versus a public cloud might actually make a lot of sense for you. Other than a rule of thumb like that, it's actually really hard to say whether one cloud or another actually makes the most sense for any application space without a deeper consultation on that. So again, I'll stick around. We'll let this run for at least the next 10 minutes. If folks have questions, I'm watching the chat, so let me know. Oh, thanks, Kumar. I appreciate the feedback, and I'm glad that this provided some ways of thinking about it. I'm not sure I actually answered your questions directly. I hope that the indirect responses were still enough to sort of help you understand some of the nuances of making these sorts of decisions. That's a good question. I have not. I have actually not seen a decent hybrid management tool. There are systems management tools, and one of the questions is, or one of the ways of thinking about this question is really sort of trying to understand when we talk about a hybrid cloud or a hybrid management tool. We're really talking about things where people are looking at different services in different ways. There are tools that are able to manage a private and public cloud and application resources against those clouds. But I have yet to see sort of one central billing interface or sort of not billing so much as chargeback-like interface or resource view of that nature today. So maybe it's a product idea. Maybe I should patent it. But I think that there is maybe a gap there, and part of that might come from the fact that there may be no one consistent consumption model. Again, somebody might be using the public cloud to deal with service scale, and might be using a private cloud as a way of supporting a storage backend. There's really no one way of describing a tool. I mean, you could build a tool that can do that. But describing a set of generic tools that would do that, I think, is maybe outside of the scope of what most people actually see. And maybe that's why there really is no one hybrid portal for everything, at least that I've seen today. So there's a question here. Once I go to the cloud, do I assume the host automatically mirrors? Ha! This is a very good question. So there are hosts that provide disaster recovery for cloud users, and provide that directly from the very get-go. It's a core part of their cloud service model. And if you ask me to name one, I off the top of my head can't think of one directly. Most companies, actually, I take that back. You know who will do something like that? DigitalOcean is an example of a cloud vendor that has at least the ability to run a snapshot service. Basically, I believe it's weekly is what they schedule, and maybe you can actually tweak the scheduling on that. But part of the difference with cloud is that most cloud services, when people talk about cloud and they're saying, oh, I'm going to go use this cloud provider or that cloud provider, usually they're talking about service from the perspective of automating a scale out application. At least that's the sort of mental picture that people have. And they've built their application to work in that cloud service space. There are also folks that talk about the difference between a web scale and an enterprise application, where an enterprise application is something that is maybe a little bit more statically defined and statically deployed, expects to have consistent backups performed against it all the time, and the recovery model is the inverse of that. You know, when can we actually get back to this? I'm not sure I quite answered that, but so mirroring is something that often is application specific, and other than sort of the disaster recovery backup kind of strategy, I don't know that there are any people out there that automatically replicate your instances into multiple locations. So Jirohead, I don't know if that answered the question, but hopefully that provided at least some context. Kumar, the question is, will you be sharing your slides or at least the contents? Yes, the slides. I think I can share the slides on the YouTube live page. We'll also post them to at least a link to the meetup page. I'll probably throw it up on SlideShare or something like that. And the YouTube link that you have, I think there will be a different one. We'll post that on the meetup page as well for the recording. So the recording will stick around for as long as YouTube's around, I guess. What services do IT managers usually try to move to the cloud first? Usually development is the thing that is driving cloud consumption interest from an IT perspective. So when you have an IT environment where somebody is looking to actually build a cloud, or is being told go get cloud and go do something with cloud, the thing that makes the most sense usually is the development environment. Beyond that, user services that have a scale component to them are things that are usually best suited to the cloud, because often the application was developed with cloud in mind. The inverse to that is, if you have applications that are constantly being updated or need to be managed in a much more efficient fashion, really supporting things like software as a service functions. So IT functions where end users want to be able to request a new resource to be deployed. One way of thinking of it is, if your end users can ask for a SharePoint server, and effectively in the past, people would get a single server every time they asked for something like that, making that a cloud function, something where potentially you have a software as a service catalog available for your end users, that's a pretty common approach for IT management teams to actually enable cloud services like that. So there was another question then: if storage is storage redundant? So in most cloud environments, there is no guarantee for any of the services. Certainly there are clouds that have SLAs, they have data backup guarantees and things of that nature, but most cloud providers say, it's basically as is, no guarantees of reliability. I think actually Amazon used to never give an SLA at all. They gave you no guarantees of using their environment. For data that you're going to at least that I've seen, where data centers, entire data centers have broken. EMC provides amazing solid storage background or backends, but that doesn't mean that it can't be for large storage providers that had a major outage in the cloud environment. The recovery to those systems is sometimes impossible, if for no other reason than just the quantity of storage that's actually in cloud environments is so high. So if you're going to deploy something into the cloud, you should have some form of backup strategy, which might be to replicate it to another data center from the same company. That's a valid model that many people have used. And in some environments, that's actually low-cost operation. No cost in that sometimes they'll actually provide that as a service. So it's just a part of the actual cloud deployment, or low cost in that sometimes the bandwidth for doing that class of replication is considered a part of the service again. So it's not an additional cost. Were there additional questions? Questions or thoughts about next meetup topic, certainly do post those onto the meetup channel, or drop us a query here if you would like to do. The other thing is that we actually do also have a newsletter that we send out once a week. If you haven't signed up for that, you might want to pop over to kumel.us and sign up for our newsletter. That might provide you some additional insights. We usually try to talk about current topics in the space, provide some news updates, and generally try to provide interesting data along the lines of sort of what we talked about here today even, and kumul.us is the website if you wanted to pop over there and sign up for the new. We'd love to have you on the list. And other than that, thanks for attending. We look forward to having you at the next meetup.